All right, today and tomorrow we're going to be looking at some of these inscribed angle properties in circles. So first let's talk about what an inscribed angle is. Okay, so an inscribed angle is an angle with its vertex, its center, on the outside edge of a circle. Okay? An intercepted arc is created by the angle, its endpoints. Okay, so up here, this is my inscribed angle, and this is my intercepted arc down here, which is created by the endpoints of my angle. So the relationship here, what happens is the inscribed angle is half of the intercepted arc. All right, down here, another thing that sometimes happens is inscribed angles that have the same intercepted arc are the same measure. Okay, so down here, these both have an intercepted arc of AC, which means that these two are the same measure. Okay, and then the last thing that happens, if they use the diameter, or this intercepted arc is a semicircle, then that means that this is a right angle. Okay, so let's type that out. If an inscribed angle is on the diameter, then it is 90 degrees. Okay, so those are our theorems we're working with today and tomorrow. All right, so starting down here are some examples. You need to be careful on the difference between a central angle and an inscribed angle. Okay, this 38 is a central angle, and we learned that central angles have the same measure as their arc. So down here is 38. So that's the measure of arc 2. Now, this is an inscribed angle, and so therefore it's half of this measure. So half of 38 would give us 19. All right, so similar on this one, angle 2 is a central angle. So it has the same measure as its arc length. So here we have angle 2 is also 114 degrees. Angle 1 is an inscribed angle with the arc measure being 114, so half of that would be 57 degrees. Okay? So here, when you figure out 1 and 2 again, this is an inscribed angle, so the length here, the arc measure, is double. So 18 times 2 is 36. Okay? If I know these three, then I can find this last one by taking 360 minus 136 and 134. So this last one is 90. So my inscribed angle is half of that, or 45 degrees. Okay, an inscribed quadrilateral is what we're going to talk about next. And the key here is that all of your vertices are on the outside of the circle. Okay, you don't have an inscribed, here I'm going to add inscribed quadrilateral unless all your vertices are on the perimeter of your circle here. So what happens when you have this is, if I put some symbols in here, the opposite ones, like here my square plus my dot is 180. Or my star plus my plus is 180. Okay, the angles that are diagonal from each other are 180. I'm going to go ahead and show you why this works. I'm going to prove to you that this is a relationship. So let's say I'm looking at this square here. This square creates an an intercepted arc. Okay, and the relationship between these two is that the arc is twice as big as the angle. So 2 times this is your arc. Okay, now let's say we look at this dot. Use a different color. This dot creates an intercepted arc, DAB. And its relationship is that it is twice as big as the angle, so 2 times the dot. Okay, we know if we add these two arcs together that they should equal 360. So if I were to add my two arc lengths, that should equal 360. If I use substitution and replace this with 2 square and 2 dot, and I factor out a 2, and divide by 2, then I get this relationship equals 180. So this will hold up for the other two angles as well. If they are diagonal from each other, they are always going to add up to 180. That's just, and this is the proof of how I can show that. And then you just need to know that that's a relationship that happens for inscribed quadrilaterals. Okay, so some examples here. I know that angle 1 and the 64 degrees have to add to 180. So angle 1 must be 116. Or I know these two have to add to 180. So angle 2 must be 122 because I have to take 180 minus 58. Okay? This next one, I need a starting point. So I know that angle 1, since this is a diameter, its inscribed arc is 180. Half of that is 90. Okay, this is one of our theorems from the page before. Angle 1 is 90. Then I also know if these two have to add to 180 that this one is also 90. So I can find my last angle, angle 2, by taking 118 minus angle 2. Or actually, I think angle 2 is talking about just this little piece. Actually, the whole thing. We'll say it's the whole thing. It's kind of misleading. It could have been just this little piece, but we'll say it's the whole thing. So if I take 180 minus 118, we'll say it's 62 degrees. All right? Okay, here, first, I have a central angle of 102, which means this whole section I just highlighted is also 102. Now this is connected to an inscribed angle of 1, and the arc is twice that length, so that means that angle 1 must be 51 degrees. Okay, then I also have an inscribed quadrilateral where all 4 points are on the outside of my circle, which means that these two angles have to add to 180. So 180 minus 51 is 129. All right. Your assignment for today is to work on worksheet 6, which is pages 31 and 32 if you numbered them, or it says worksheet 6 at the top.